Good morning, good afternoon, and good evening, everyone. My name is Ken O, connecting from Sydney. Um, on the other side of the planet, it is 6 a.m. on an autumn morning. It's not very early. Before the presentation, I'd like to thank all contributors and maintainers of this project because you have created one of the best tools in the cloud governance landscape. In the next 15 minutes, I'm going to present to you proactively maintaining cloud security hygiene with Cloud Custodian. As we know, Cloud Custodian supports multi-cloud providers such as AWS, Azure, GCP, and others. With more and more services moving to the public cloud, misconfigured cloud infrastructure presents significant security risks. From an operational point of view, security requirements can usually be grouped into two categories. Common requirements like standards, compliance, or benchmarks. And the second one is organization requirements like policies, best practice, automation, integration, and remediation. Cloud Custodian can help us implement and enforce those requirements. So since the organization requirements vary, so let's take CIS benchmarks as an example. There are 5 domains and 64 controls in version 2.0 for AWS. For instance, control 1.8 is about password policy. 2.3.1 is about RDS encryption. 3.1 is about cloud shell enablement. And 4.3 is about monitoring the root user usage. And 5.3 is about ingress rules of security groups. For each of them, Cloud Custodian is capable of implementing them in less than 20 lines of YAML configuration. For some of us who are not very familiar with Cloud Custodian, here is what the 20-line YAML configuration looks like. This is to implement the control 1.8, ensure IAM password policy requires a minimum length of 14 or greater. We specify the resource type as account, use the password policy filter, and specify minimum password length as 14. This filter will identify any non-compliant accounts and allowing us to take actions such as notification so that we may follow it up later. Let's examine another control, RDS instance encryption. We specify the resource type as RDS, use the value filter to identify an instance with storage encrypted attribute, the value set to false. At this time, the policy execution logic is a little bit different. We specify the mode section so that the policy will be deployed as a Lambda function to monitor the create DB instance cloud shell event rather than regularly scan all RDS instance. Upon identifying such instance, we delete them directly. So in the real world, we don't delete resources like that, but this is just to showcase the capabilities of Cloud Custodian. Here's more examples. This one is to monitor if Cloud Shell is enabled properly, around 10 lines of YAML configuration. And I'm going to move to the next one. This one is monitoring root user usage. Is around 20 lines of YAML configuration, including the notification actions. Notification plays a significant role in our operations. For any findings or remediations, we should notify the relevant parties. The Mailrun tool with Cloud Custodian provides multiple ways of sending out notifications, such as through email, Slack message, Datadog, and some others. So it's pretty handy. The last example is about security group ingress. It took around 20 lines of code. I could keep going, and in my experience, automating all these CIS benchmark controls would only take a few weeks if we have a solid foundation. Now, let's move on to some challenges we might encounter. The first one that immediately comes to my mind is organizing the policies and other necessary source code. I suggest we group policies by cloud providers, AWS, Azure, GCP. Each of them will have a dedicated folder. Within these folders, create a policies folder to hold all policies, which each policy file prefixed with the resource type, so that can group them together. There are additional folders for different purpose, but I'd like to highlight the tests folder. This is where we store all automated test case for our policies. Although Cloud Custodian has thousands of test cases, having our own test cases is necessary, especially for those destructive actions like deleting security group ingress. It will be a disaster if thousands of security group ingresses were deleted by accident. So our test case can also help reduce the risks from the supply chain. Speaking of the supply chain risk, let me share a real story with you. I wasn't the victim. In fact, I introduced the risk at that time. At that case, one day I received a common notification on my PR, and the user was frustrated, saying that all the policies conditions weren't work after updating to the latest version. It took them quite a while to troubleshoot. I felt so sorry, so I thought, oh, geez, what have I done? And I immediately review my changes and communicate with the user. As the cloud custodian is so powerful, so any misbehavior could potentially cause significant damage. But fortunately, the policies were only being skipped, so nothing destructive occurs. As a contributor, we strive to maintain a high standard, but sometimes certain edge cases may still be overlooked. So that's why running our own test case to ensure expected behavior is crucial. And also, Cloud Custodian has a really good testing framework, and if that doesn't show your case, then we can build our own one. So the second challenge is that with so many compliances to meet, developing hundreds of cloud custodian policies could become costly. For those common requirements, my suggestion would be to integrate with your existing commercial security product or via open source solution. Previously, I came across an open source tool called Steam Pipe. It has 43 modules mapped to multiple providers. And the AWS compliance module you're seeing here is one of them. The module implements 993 controls, covering almost all the common compliance I know. One possible integration looks like the example showing here. This is control 2.2.1, ensuring EBS volume encryption. We specify the resource type as EBS and then use the Steam pipe for filter, provide the control key and set the status as alarm. Now all the non-compliant EBS volumes will be found, and we can take any necessary actions. The bad news is that the Steam pipe filter is not ready in the Cloud Custodian yet, but the good news is it's not too difficult to implement. The last but not the least challenges is end-to-end automation. Engineers developing Cloud Custodian policy and pushing them to the GitHub repo is just the first step. After that, we need to build our CI/CD pipeline, deploy or schedule the policies to monitor or regularly scan our target AWS accounts. For any findings, we will need to notify operation teams and resource owners. After any remediation, we shall allow on-demand verifications to ensure each has been solved properly. For this automation workflow, every organization is unique. So coordinating multiple teams, requesting everyone to follow a new standard could be challenging. So don't underestimate this part in your journey. So in a summary, for detection, we have out-of-box filters. There may be thousands of them. I don't know. I haven't counted, but just many of them as out-of-box ready for use. For alerting, we have C7 and malware. For remediation, we have built-in actions. It offers the best flexibility with zero license cost. At the moment, the project has 5,000 GitHub stars, but in my opinion, it's an understatement. So welcome to explore the project and contribute to it. Thank you. Back to you, Umir.
Great, thank you so much. Which come on a good topic. Who hasn't given Cloud Custodian a star recently? If you have not, like you'll be surprised, a lot of people contribute and they forget to start it. You are absolutely right. We should have more than 5,000 stars. When we have 422 contributors, that's pretty rare for an OSS project, for sure. Any questions for Ken? I didn't see the chat window yet, sorry.